Okay, so mid dot and bullets are different. The way you get mid dot by way of keystroke or shortcut, I believe it's Shift Command 9, and that's midpoint, mid dot, multiplication right there, just a bit cleaner, right? So that's all this is. This is just the entity name. All right. And then the second factor, same as this guy, except index 2. And, this is just kind of editorial, right? So here I have now, instead of writing out mid dot 3 times, I just, do my Shift Option 9 and put the actual symbol that that I'm intending to use right in there, part it by a space here, and then using these entities, thin space. This is an editorial decision that one can make. So it's preference of how it looks to you. But we're going to treat that as an operator, most importantly. All right. And then our final factor. Subscript, indicator P, variable, right? Unknown, index N. So that's our final indicator and index N, whatever. Our final factor, right? Closing subscript, closing parentheses. And again, we want some sort of code aesthetic to be part of what we're doing whether we're marking up in MathML or we're programming in C++, doesn't really matter. You want to have some sort of good habits in terms of code writing. Close the row. We're going to close our first, we're not closing our first underbrace yet, but remember, we have our underbrace right here. Close the subtending first subtending character. And the second one, right beneath that, goes right in here, fits right in there, right? The N under the underbrace, right? Our index, our counter, right under the underbrace. And then we close that. And then we close that guy. Then we close the math tag, close the math stack, and we're on our way. I'm going to hit cancel because I haven't made any edits here. Yeah, and I'll point out that for the second factor, numeral, well, not numeral, but number, right? For the second, for the second factor, we could have that in here, obviously, but the reason I broke it up into 2 is because, again, it just makes the code, there's just less to look at. So no loss, no harm, no foul in terms of breaking these 2 guys up. No harm, no foul. All right, so per theorem 1, P and Q up to the order of their factors each have distinct prime factorizations. And here we're looking at what that looks like for P. P squared. It follows that P squared has an even number of prime factors. Why? Like we said. Well, P has a number of prime factors, n number of prime factors, We don't really care how many there are at this stage. And all we're doing is doubling that, p squared. So there's 2 times the amount of prime factors that produce p squared. That's an even number of prime factors. And so does q squared. It's the same deal. It's an even number of prime factors. Okay? Because q has n number, has a number n of prime factors. If this were q squared, it actually, let's say m, Martha, right? Number of prime factors, and then q squared is, again, just a doubling, so we end up with 2 times that many, so it's an even number of prime factors. However, this contradicts equation 2, or step 2, previously established up here. Okay, what does that look like? So this contradicts 2, as 2q squared, thereby, would have an odd number of factors in its prime factorization. We have this extra 2 in here, don't we? Right? Q squared, we just established, would have an even number of prime factors. Well, given our previous assumptions, p squared would also have this guy in there. Contradiction. So 2q squared would thereby have an odd number of factors in its prime factorization. That's our assumption that the square root of 2 is irrational, must be ejected as invalid. Okay, so lots of good proofs out there to sort of really hone in this intuition around the square root of 2, but also proof by contradiction. So hopefully this was enjoyable and gave you some value. And in the next video, I think we're going to be getting right into the problem sets here for this chapter. So yeah, appreciate you sitting through. Give it a like. If you haven't, consider giving it a subscribe on the channel. And I'll see you in the next one.